Class.
Yes.
Christian.
Yes.
Nephi. What's up?
I started first.
I know you did. Faye. Oh. Anyway, Euler's method. So we're approximating a particular solution of a first order differential equation. So given a first order differential equation means that what is a derivative? It gives me the what? The derivative? Slope. Not equal 0. Just the derivative itself is going to give me a slope, right? Okay. So the derivative is going to give me a slope. So if I have a first order derivative and I'm looking for a particular solution, so I have a starting point that I'm going to approximate from. And then I'm going to take increments. I'm going to make a step. And my increments are small arbitrary increment right here in the x to get to the point where I'm going. So I could jump in and try and approximate it where it is, or just little piece at a time by keep getting closer and closer to that by using the h. It'll make sense in a moment, okay? So my formula's right there. Where's my formula? Formula's right here. And so y sub naught means it's my initial, and y1 means that's going to be my first iteration. So I have a certain value here that I know, but given the slope, I want to try to get closer and closer to this by approximating. So h, yes, that guy.
Yeah, when you said notes are gonna happen. None of mine are stable, so they always get mixed matched. I don't even know what's what.
I just got done printing one. So here. This isn't going to take very long. Okay. All right, so now Euler's method. Suppose you have y equals y of x, the solution to the differential equation. So this right here is going to give me the, say slope, right? The dy dx, that's going to give me a slope at a certain point. Yes? Okay, good. So with the boundary initial condition, so I'm starting somewhere, that's my x, my initial x and y, so that's my x sub naught, y sub naught. Use Euler's method to approximate, so I want to get to this, so that means that when x is 1.5, because this says this is my y of x. Okay, and it says increment of 0.25. So what's my x starting at?
Oh,
It's 1, right? So after I do it the first time, it's going to go up 0.25. Second time, it's going to go up another 0.25. And the third one, okay, it's going to go up another one, right? That's where I get there. So that's what it means about the iterations and keep going on this. So it's getting closer and closer and closer to that point that I'm looking for. So starting this out, I'm going to start with, so I get y1 is equal to y sub naught, which is my original, which is 2, plus my formula says h times f of x, right? Or f of x and y. So I'm going to plug in those. So h, what was h? H is 0.25. I don't like decimals. I like fractions, because fractions are your friends, not food, right? Okay. So 1/4 times, now, f of x and y. So that means that I'm going to plug my x and y into there. So x is 1, y is 2, plus, that's weird that it changes colors on me, 1 squared, right? Yes? Okay, do a little bit of math right there. So 2 times 1 is 2, plus 1 is 3. 3 times 1/4 is 3/4, plus 2. Is that like 2.75? Okay, so do you agree that this is 3? 3 times 1/4 is 3/4, right? Isn't 3/4 0.75? 3/4, right? 0.75 plus 2, 2.75, isn't it? Yeah? Okay, so 2.75. So I'm going to get y1 is equal to, if you notice I changed it into fractions, from fraction to the decimal, because this could be a little bit easier from here. Because it is going to get kind of crazy here in a moment. So this is my first iteration, right? So I just increased my h to 1.25, right? So using the first one, I increased it by that amount. So now I need to increase it again. So I'm going to increase it again. So I'm going to say y2 is equal to the previous iteration, not my original, because I'm going to y2, right? So what do you think should go here? We're going up in steps here. What was it in the first place? 2. It was 2, right? But where did 2 come from? My initial y, right? Okay, but I'm moving up in iterations. So that means that I am no longer going to use this one, because that's not my initial. I now have, this is my now y1, right? So in my y2, I'm plugging in my y1. Make sense now? So as I keep going, I'm going to use the next to try and get to my third one. So that means that I'm going to plug in 2.75 plus, I'm going up how much? 1/4, right? 0.25. And for the sake of, I'm keeping it looking like this, because that's my increment that I'm going up every time. Because I hate multiplying by decimals. Because you have to do that thing where you carry the 1 and you X out the move a space over and all that. Okay. Then it's going to be f of x and y, right? What's my new x? I got my new y, but what's my new x? Say it? 1.5. Not there yet. Not. How much did I go up in this previous one? 2. How much did I go up? 1/4. I went up 0.25, right? So that's my increment. My x is going up every time. So if this was 1, my next one's going to be 1.25 times, what's my new y value? 2.75 plus 1.25 squared. And yes, you could use a calculator on these, because I really don't want to do all that multiplication. Alright, so we had 2.75 plus 0.25 times quantity of 1.25 times 2.75 plus 1.25 squared. Did I insert that correctly? I hope so. Okay. I get 4. So my new y value, my y2, is 4. So at this point right here, I have, so given this point, I know that y2 is 4. So I increased all this to get y2 being 4. So that means that right here so y sub naught was 2, x sub naught was 1. Y sub 1 was 2.75 when x sub 1 was 1.25. Does that make a little bit more sense, showing it item by item as I go? All right, so that means that y2 was 4 when x2, what was my x2 going to be? 1.5?
It's
Alright.
added 1.4, not multiplying each time, right? To our x value. after
Yeah.
differential.
So I gotta go and do this one to get my y third. So one more time is equal to 4 plus my 1/4 that I'm increasing every time because that's my h value. Then it went 1.5 times 4 plus 1.5 squared. I get 6.0625. Or it rounds it to, what do I always round to? Third, right? 0.63. And one thing that always gets me on this is when was I supposed to stop? So you stop this one here when we're doing this when I plugged in that x value that they were looking for. Because right here said for this, when I plug in 1.5, that's my last iteration I need. And so since it said an increment of 0.25 starting at 1, I had 1, 1.25, then 1.5. So that's why I had to get my third one there. And this is for approximating what it is going to be, which is going to be this point right about here. Okay. All right, that being said, that's it. Make sure you all like, share, and subscribe.